Hello viewers, welcome to another episode of Knowledge Sharing. Before we continue, like us or like and follow our Facebook page, subscribe to our YouTube channel, comments and share our video for more interesting topics. Today we are looking at this question and it says, in this equation, x to the power of 2 equals to x to the power of 5. What is the value of x? So in this case, we are going to look for the value of x. So we have solution. We are given x to the power of 2 equals to x to the power of 5. If we can recall that in indices, when we have a to the power of b equals to a to the power of c, therefore, we always say, since two of them have the same base, we always say that b equals to c. But in this case, not all the time that this expression is correct. But in this case, we cannot say that 2 equals to 5. 2 cannot be equal to 5. But we are going to find the value of x, that when you raise to the power of 2 will be equal to x when you raise to the power of 5. So what are these value of x? It's not going to be one value of x. It's going to be one or two value of x, that when you raise to the power of 2 and you raise to the power of 5, they will all have the same value. So in this case, we are not going to use this law of indices, or this law of indices does not apply to this equation. So here, the first step that we are going to do is for us to move this, transpose this into this other side. So it will become x to the power of 5 minus x to the power of 2 equals to 0. So this is what we have. Now we can go ahead to simplify this. X to the power of 5 is the same thing as x to the power of 3 times x to the power of 2, because we all know that in indices, when you have a multiplication of the same base, you can always add the powers. This becomes x to the power of 3 plus 2. X to the power of 3 plus 2 gives us x to the power of 5. So this expression, you are going to replace this with this. So this will become x to the power of 3 times x to the power of 2 minus x to the power of 2 equals to 0. So this is what we have. So now we have a factor between this value and this value. So we can factor it out. So this will become x to the power of 2 is a factor of these two. So now x to the power of 3 times x to the power of 2 divided by x to the power of 2 will give us x to the power of 3 minus x to the power of 2 divided by x to the power of 2 will give us 1. So this is what we have equals to 0. This is the same thing as x to the power of 2 all into x to the power of 3 minus 1 equals to 0. So in zero product rule, we all know that it is either the first parenthesis equals to 0 or the second parenthesis equals to 0. So the first one will be when we have x to the power of 2 equals to 0, or x to the power of 3 minus 1 equals to 0. So this is what it means. So now, in the first one, we have x to the power of 2 equals to 0. We can apply square root to both sides. So x to the power of 2, square root of x to the power of 2 equals to square root of 0. That is plus or minus square root of 0. So in this case, we have, when we have square root of x to the power of 2 equals to plus or minus square root of 0. So here, this one will cancel here and this one will cancel here. Then our x equals to plus or minus square root of 0. Square root of 0 equals to 0. So we have plus or minus 0. Here we have two values of x. x1 equals to plus 0 and x2 equals to minus 0. So these are the value of x that we have for this, the value of x, and one of the factors of this equation that we have that can satisfy it here. So you can see that when you substitute x equals to 0 in this place, we have, when we have 0 raised to the power of 2 is the same thing as 0, and we have 0 raised to the power of 5 is the same thing as 0. So it satisfies this expression. So those are the first two values of x. Let's look for the other value of x. So we have the second one where we have x to the power of 3 minus 1 equals to 0. So The second one will be x to the power of 3 minus 1 equals to 0. This one, we can write 1 raised to the power of 3 is the same thing as 1. So we substitute this into where we have here. So we have x to the power of 3 minus 1 to the power of 3 equals to 0. In this case, this is the same thing as when we recall when we have a to the power of 3 minus b to the power of 3 equals to a minus b into a raised to the power of 2 plus ab plus b squared. So this is what it means. So we are going to express this in this format. Therefore, x to the power of 3 minus 1 to the power of 3 will be x to the power of 3 minus 1 to the power of 3 will be x minus 1 into x squared plus x times 1 plus 1 squared. So that is what we have. So now I can expand this. So we have this will become x minus 1 into x squared plus x plus 1 equals to 0. So this is what we have. So now we can move over to this other side. So as you said, move to this other side. As you said that we have x minus 1 into x squared plus x plus 1 equals to 0. So in this case, this is our x raised to the power of 3 minus 1 raised to the power of 3 equals to this. Our zero product rule says that the first parenthesis equals to 0 or the second parenthesis equals to 0. So let's take the first one where we have x minus 1 equals to 0. Then here, minus 1 will be transposed into the other side. We have x equals to 1. So in this case, we have the first value here and we also have the second value here. So our x3 equals to 1. So this is our third value of x. So we have this. This was the first one and this was the second one. So this is the third one. We have the second parenthesis which is equal to 0. So we have x raised to the power of 2 plus x plus 1 equals to 0. And we can see that this is a quadratic equation and we are going to use a quadratic formula for also find the value of x in this expression. So we have our x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. In this case, we have our a equals to 1, our b equals to 1, our c equals to 1. The coefficient of x squared is equals to 1. Here we have 1 and see here constant we have 1. So we are going to substitute this into where we have this. So we have x equals to minus 1 plus or minus square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. So this is what we have. This will become, let's clean this. Okay, now before we clean this, let us write this. Here we have x1 equals to plus 0, then our x2 equals to minus 0 before we clean this. So now what we have here, we have for here we have x. From here we have x equals to minus 1. This is plus or minus square root of 1 squared is 1 minus 4 times 1 times 1 is going to be 1 minus 4 all over 2. So this will become x equals to minus 1 plus or minus, then we have square root of minus 3 all over 2. Okay, this is plus or minus. Inside here we have two value of x in this solution. Or before we simplify this will become minus 1 plus or minus square root of 3 times I. I is iota because we have, when we have square root of minus 1 equals to iota. So that's why we have square root of 3 times I, which is the iota. So now we have this. Therefore, x will be equals to minus 1. We take the first one plus iota root 3 all over 2. But we can rewrite this. This can be written as iota root 3 minus 1 all over 2. So this is the value of our x. We have x3 here, our x4. So our x4 is iota root 3 minus 1 all over 2. So our x5, which is the second value of x in this expression, we have x5, which is equals to, the second one is going to be negative sign. So it's going to be minus 1 minus iota root 3 all over 2. So in this case, we can expand this with a negative value for us to have the positive value inside, like this. So now this will become x5 equals to minus 1 into 1 plus iota root 3 all over 2. So this is the value of x5 in this expression. So we have the 5 value of x that satisfy this equation. The x1 is this, the x2 is this, and our x3 is this, our x4 is this, and our x5 is this. And all of them satisfy this expression that x to the power of 2 equals to x to the power of 5. If you like what we are doing here, follow us on our Facebook page, subscribe to our YouTube channel, comment and share our video for more interesting topics. Thank you.